Lesson number 93 is about classifying triangles, and this first table shows us how to classify triangles by their sides. If we want to classify triangles by their sides, we can have an equilateral triangle, we can have an isosceles triangle, or we could have a scalene triangle. Now, an equilateral, well, that just refers to a triangle that has all three sides equal length, and we can see a picture here of a triangle that has all three sides that are equal lengths. An isosceles triangle looks like this, potentially, and the definition or description for an isosceles triangle is a triangle that has at least two of three sides equal lengths. So this one are two sides that are equal length. They must be here and here are two diagonal sides. But notice the definition for isosceles, at least two of three sides equal length. So if three of three sides were equal length, like an equilateral triangle, that would also be an isosceles triangle. A scalene triangle? Well, here's a picture of a potential scalene triangle. The definition is all three sides have different lengths. Please pause the video now so you can get this table copied into your notes. Let's look at our next table. Now we can classify triangles by their angles. And the three different types of triangles that we could have would be an acute triangle, a right triangle, or an obtuse triangle. Now an acute triangle, here we have a picture of one. The definition says all three angles are acute. So notice that all three angles here are definitely less than 90 degrees. So this is an example of an acute triangle. A right triangle has one angle that is a right angle. And of course, a right angle, that means 90 degrees. And we can show our right angle here with our box in the corner. That means this angle is 90 degrees. An obtuse triangle is an angle, or one angle is an acute angle. And that definition is not correct. Let's fix that. Okay? For an obtuse triangle, one angle is an obtuse angle, of course. Because if we only had one angle that was an acute angle, well, that would only tell us one of our angles. So there we have the correct definition for what an obtuse triangle is, when it has one angle that is an obtuse angle. So our obtuse triangle here, well, our obtuse angle right here, it's greater than 90 degrees. And of course, it's only possible to have one obtuse angle in any triangle, or else you wouldn't have a triangle because it would have to have more than three sides. Please take a moment to pause the video now so you can get this table copied into your notes as well. We have two examples today to work from these tables. First one says, an equilateral triangle is also an acute triangle. Now, if it's also an acute triangle, well, as we go through that, we need to draw a picture to help us with this. So, an equilateral triangle. Here is a potential equilateral triangle. We can show it's equilateral by saying all the sides are the same length, and we do that with our tick marks, one on each side. Is an equilateral triangle also an acute triangle? Well, if we look at the angles, this one's less than 90, this one's less than 90, and this one's also less than 90 degrees, so it must be true. An equilateral triangle is also an example of an acute triangle. We've got our answer. We can move on to the next question. One key with these problems is to draw out a picture to help you visualize or see what's happening with the problem. Let's look at our next problem. One side of an equilateral triangle measures 15 centimeters. What is the perimeter of the triangle? So again, if we have an equilateral triangle, here we go, that looks pretty good. If one side of the equilateral triangle measures 15 centimeters, what is the perimeter of the triangle? Well, equilateral, that just means all sides are the same length. So since we have our measurements now, all we have to do to find out the perimeter, the distance around the outside of our shape, is to multiply 15 times 3. 3 times 5, that's 15, and we'll carry our 1. 3 times 1 is 3, plus 1 more is 45. So we're going to get an answer of 45 centimeters, We need to have our label because we're talking about a distance around the outside of a shape. And we've got our answer. Again, drawing a picture here can be very helpful in the process of figuring out the answer to this question. Our lesson practice will be on page 500. Make sure you've got your notes complete, and I'll see you during our next class.